In this video, we will look at the process of getting a design ready for 3D printing. We will use the Z-Suite environment from Zortrax since that is the printer I use. However, a similar process will apply to other 3D printing software. For this example, we will use the project enclosure we made in the video about Onshape. When you first open up your environment, it will look something like this. You'll have this blank kind of area that shows you where your 3D printer is actually going to go. So this actually simulates the look of the platform of the Zortrax printer, but other software will look slightly different, but it'll be the same idea. So what we're going to do is we're going to first import our parts. So I'll import both of the parts that we had created, the box and the cover, and we want to then arrange them for 3D printing. Well, I can move parts around on here using this move tool, so I can grab something and just move it anywhere I want, and this software will be nice. It'll tell you when things are intersecting, when things are off of the printing platform altogether, and so on. And you can put them anywhere you want, but it usually makes sense to put them somewhere towards the middle to minimize the print area. And in fact, here you can use an auto arrange feature, and so it'll just place them nicely for you. And so here we can look at our parts a little more closely, and we can make some other modifications here. Instead of just arrangement, we can also perform things like rotation, which is sometimes going to be useful depending on how you actually designed your components. So for example, if I grab this component right here and I rotate it by, let's say, 90 degrees and put it on its side, well, I can still print this. However, it's going to be a very inefficient print. When it's staying like this on its side, in order to actually print this, well, since there is a part that's sort of hanging in the air, this wall is sort of hanging in the air, there's nothing below it really, the 3D printer would have to print a support structure that would go all the way up to that top. And that would be very, very inefficient. It would use a lot of material that would otherwise be unnecessary. So it makes the most sense to leave this at 0 degrees, because that will use the minimum amount of support structure when we're printing this, since there's nothing that's sort of floating in the air. And the same thing with this cover. Okay, so once we've arranged our items here, we can go to print, and then we're going to have several options. And again, different software will provide you with different options, but with this one, the options are actually more on the simple side. We choose a material, so I'm using ZABS. We choose a layer thickness, and here I'll just go somewhere middle of the line at 0.19 millimeters. I usually choose high quality. Then the amount of infill, that is how much is going to be placed, how much material will be placed in the walls, and I'll go somewhere with medium since I don't need this to be particularly sturdy of a structure. It's just an enclosure. And then the support here, this refers to that support I was talking about where it'll print the support structures. Here it will have to actually print a support structure for our port hole on the side, because again, it has a part that's sort of floating in the air, and therefore it'll need to build supports up in order to build that. And so support light here is just a good idea. It makes the supports easier to remove later, and this is the angle at which it starts to print the support, and 20 is fine, so I'll leave it at 20. And then we say prepare to print. So then it's going to go through this process where it lays out a track for the 3D printing head. And once it's done, it's going to give you a look that's something like this, again, depending on your software. And here you can analyze this, just take another look at it, and you can see that it prints this raft on the bottom, which is pretty common, and that raft will be removable. Everything in gray is basically a support structure. Everything in blue is what you're going to end up using. And you can also see the support that it built over here. This thing right around the hole, as I said, will have to be printed in order to make the top be a nice straight line instead of sagging as it otherwise would. And so we can also analyze things by using some sort of tool like this to analyze the individual layers, and we can actually take it down to the bottom. Here's the raft, and then this is how our structure is going to be built up, and you can see the support going along with it as I build it up, and then it builds that last edge there, and then it keeps on going. And you can analyze this, and this is sometimes useful to take a closer look at things in case there are some things that are not as you expect them, and then you can go back and make appropriate changes. So after you're happy with how your print looks, you're ready to save this to print. So we say save to print. It's going to save it as something .z code in this case, and then we'll save it. Then we can save that to an SD card, put that in the 3D printer, and we're ready to print. Notice here it also gives you an estimated print time here an hour and 35 minutes. Just to give you an idea of how things would change if I were to place the component on its side, and therefore it would require a lot more support structure, let me rotate this, as I said, by 90 degrees, and let's print this instead. Notice the whole thing is now full of support structure, so now if I go through the layers, you can see it has to build up this entire support structure all the way through in order to create that horizontal floating wall that's at the top. And this is going to increase our print time. In this case, not too much. So it went from about an hour 30 to an hour 52. And it's not too much because this box is very small. But as you get larger and larger designs, the effect is going to be more and more pronounced. One more design tool that I want to show here, not really a tool but rather a design method, is how to slice components in order to isolate parts to verify that their dimensions are correct. So we could print this entire thing, and that will take, like we said, about an hour 30, and then we can take a look and what happens if we want to just check if that nut indent on the bottom of our design is the right size and the nut is going to fit. Well, we could print, like I said, the whole thing, and then it'll take us an hour 30. We'll find out it's wrong, print it again, another hour 30, find out it's wrong again, and keep going, keep iterating, and that's what's going to happen oftentimes. Alternatively, you could isolate the part by using slicing. So I'll get rid of that part altogether because we don't need the cover in order to test this. And then I'll use a slice tool. And many programs will have some kind of a slice tool. And so then I can move this, I select my object, I can move this along, and it'll show me where I'm going to actually place this slice. So I'll place one slice right here, and I'll split this. Then I'll place another slice right here, split it again. I can get rid of these two parts, I don't need them. And now I'm going to split along the Y with this object. Right here. And right here. And now I get rid of these two, and I'm left with just this small part of our design. But remember, on the bottom, we have that offset for the nut. And so we can see that a little more clearly if I just grab this and I rotate it. That's the part that we actually want to check right there, that nut indent. And so we can print this now, and of course it's going to be a much smaller print. And that's just going to take 6 minutes, and then we can test if our dimensions are correct. And you can go back and do this for any part of your design that you're not sure about in order to test if everything is the correct dimensions that you want. So in this video, we have seen how to take a design created in a CAD tool like Onshape and how to prepare it for actual 3D printing. In other software, there may be more or different options, but this shows the general procedure.